And this is part 2 of this unit where we get introduced to combinations. Now, permutations are when you rearrange things and the order matters. A combination is how many ways you can rearrange something and the order doesn't matter. Okay? So we start off with an idea that you're allowed to pick 3 books or choose 3 books from 4 books. Let's say you won a contest that says you win 3 books and there's 4 books that you could choose from. How many different ways could you pick the 3 books? Well, you could pick book 1, book 2, and book 3. Now, if those books were arranged on a shelf, this is all the different ways you could arrange them on a shelf at home, but it wouldn't make a difference when you were choosing those books from the prize. You have 4 books to choose from, you get to take 3. You go, I'm going to take 1, 2, and 3, and you go, wait a minute. No, I'm going to put those back, and I'm going to take home book 3, book 2, and book 1 instead. The person would look at you and say, that's the same thing. It really doesn't matter. That'd be like playing poker, and you're like, oh, I was so close. I have the 10 of spades, jack of spades, queen of spades, but then I have the ace of spades and king of spades, and the order's off. I'm going to fold. Right? When you play a game like poker, you get to rearrange the cards in your hand. It doesn't matter the order they were dealt to you in. So this opens up a whole different type of counting called combinations. So you could have chosen book 1, book 2, book 3. You could have chosen book 1, book 2, book 4. Book 1, book 3, book 4, or book 2, book 3, book 4. Whew. It's going to be fun. It's fun to say book that many times. So in permutations, we would have had 24 different permutations, but in combinations, we only have 4. And just like when we had identical objects and we divided to get rid of certain examples that were the same thing happens in combinations. A combination is a permutation where the order is taken out. And notice that there are 3 factorial or 6 in each. For every combination of 3, there would be 6 permutations. Because 3 items could be arranged in 3 times 2 times 1, 6 ways. And so all a combination is a permutation with the order taken out. So we take our permutations and we divide by 3 factorial because that would be the order of 3 objects. And we find out that there's 4 ways that you could choose your prize. So we get to our combinations formula, which again, it just shows here that it is your permutations formula with the order divided out. And since your permutations formula is n factorial over n minus r factorial, your combinations formula is n factorial over n minus r factorial with another r factorial on the bottom. And with your permutations formula, you almost never used it because we could use spaces more often to figure it out. But we will be using our combinations formula a lot. Okay, some textbooks for your course and on the exam, they'll use this notation, n choose r. Textbooks later on, maybe in university, or if you're taking IB courses, they use this notation with brackets and the n on the top and the r on the bottom. And with the C, I like to say n choose r. Permutations might be n pick r or n place r because the order matters. So the number one difference between combinations and permutations is whether or not the order matters. And that's going to be your now new first question you're going to, when you read a word problem, you have to make the first decision, is this a permutations question or is this a combinations question? Does the order matter or does the order not matter? So, just some getting used to the combinations formula. If we had 10 choose 3, according to the formula, that would be 10 factorial on the top over 10 minus 3, which would be 7 factorial, and then 3 factorial. And what makes the combinations formula really easy to memorize, 47 choose 8, you're going to have the 47 factorial. Wow, that's impressive. 47 factorial on the top. You're going to have the 8 factorial on the bottom, and the other number is always what would add up to the top. So the bottom two numbers, 7 and 3 make 10, 39 and 8 make 47. So it's a really easy formula to memorize, much easier than the permutations formula. So let's look at our first example. Keno lottery. 20 numbers are chosen from 1 to 80. You don't have to get the order right, but if you choose the right 20 numbers, then you win. So a couple of things in here. This one says combinations. And so we go, wow, 80s. 80, choose 20. So we write the 80 and the 20 small. And we would go on our calculator to find out where that is. Of course, if we write out from the formula, the bottom two numbers again add up to the one on the top. But on your calculator, you can go 80, hit the math button, over to probability, and choose 20. And we get a very large number, 3.53. And they see that e to the 18 at the end. That means scientific notation times 10 to the 18. Now, how many people have heard of the Keno lottery? Not very many. Have you heard of Lotto 649? Yes? Okay. Well, let's do Lotto 649 instead then. Lotto have two T's? Sure. I think they write the 49 small, fancy like that. What does Lotto 649 mean? It means there are 49 numbers and you choose 6 of them. If you choose all 6 numbers correctly, you win the prize. And they always have the amount of money up on billboards, right? It's like, when is it big? Anything over 30 million is considered big. Does it get up to 60 million? Has it ever got that high?
At least once, probably.
So we can look that up, find out the highest it's ever got. Okay? So if you want to know how many combinations are possible with Lotto 649, there's 49 numbers. You need to choose 6. So if you do that on your calculator, see how close I have to having this number memorized. I think I'm going to be off by something. But how close am I? That's what my head says is the number. 49, math, choose 6, 1, 3. Oh, I was good up to here. 1, 3, 9, 8, 3, 8, 1, 6. Oh, I think that other number was from something else. We'll find out. Just about 14 million. How much does a lottery ticket cost? Is it $2? I think it's $2 now. I don't buy lottery tickets because I know the math, and I can't just throw away money. Okay? You do have a chance of winning. Do you want to? Okay? Questions for practice on this one? 4, 5, and 7.